All right. I think we are live at this point. Welcome on in, everyone. Hopefully everyone is having a good Wednesday evening. And I'll go ahead and start saying hi to everyone in the chat as you join in. There we go. All right, and for those of you who I can't wave to for some reason, I'll go ahead and say hi now. I'll wave now. There we go. So yeah, like that, hopefully everyone's having a good Wednesday evening. Tonight, we're going to be talking about limit laws. Let's try it again. Limit laws, there we go. And what happens when we approach infinity. So as we are getting into it, be sure to hit that hit those hearts. Again, I will welcome people in as they join, so welcome on in, everyone. As I said, hopefully, how is everyone's Wednesday evening? Mine's going pretty well. I'm not as tired as I was last night, so that's a good start. But yeah, so I'm going to go ahead and say hi to everybody who is joining in. And we'll begin in just a moment. Or should I say we'll begin the math in a moment. I will still be here. And actually what I might do is might move the camera closer to me a little bit. There we go. And I will expand that. All right. So yes, welcome on in, everyone, to this late night calculus stream. Prepare yourselves for limits, because tomorrow, so my plan for the rest of this week is tomorrow we're going to be finishing up limits for a little while. And then tomorrow we're going to be going into the limit definition of a derivative. And then on Friday, we will go into derivative rules. So that is the plan over the next couple of days. All right. Let me see if there's any more people that TikTok will allow me to click the button to wave to. But if I can't do that, let me wave to you now. Hi, everyone. So let's go ahead and begin our discussion. So tonight, we're talking about these ideas of limits. And remember, what is a limit? Well, a limit, so we write limit as LIM, as our variable, usually x, approaches some number, which I'll call a. So this says limit as x approaches a. And we can think of that kind of as like x, this arrow almost getting closer to a. There we go. Thank you for liking the live. Yes, please, please, hit that heart button. Hit those share the likes, share the live. And then once I have this, I just plug in my function f of x. This is asking us, hey man, I don't want to be that guy, but you tutored me and I ended up getting a 43 on my final. I'm sorry to hear that. I'm sorry to hear that. Fair enough. Limit to 0 of 1 over x squared. Yeah, I'll do that one. We can do that one tonight. Although, I'll get to that one shortly. So, this means, this is essentially asking, as x gets close to a, closer to a, what y value does f of x approach? Hey Dad, how's it going? Welcome on in. So this is, I'm not sure if this is the formal definition. Nope, we don't want that button. I want that button. There we go. So, you love limits? Awesome. Glad to hear that. So, what does this help us do? Well, tonight we're going to learn about two things. We're going to learn about some rules of limits, and also we're going to see what happens when a is going to be infinity or negative infinity. So those are two things that you can expect tonight. So let me go ahead and give you the 5 limit laws that we're going to work with tonight. So, limit laws, or at least for this first half. So, first, limit to infinity of 8 over 2 plus sine x, and limit to 0 of that. Okay. We'll get to those shortly. So, our first limit law that we're going to look at is what happens when limit as x approaches a of f of x, where f of x is continuous at x equals a. F of x continuous at a. Then, the limit as x approaches a of f of x is just going to equal f of a. Because if we remember, in order for a function to be continuous, one of the conditions that has to be met is if the limit as x approaches a is equal to f of a. Yo, I actually need help. The question is x cubed minus 27. So there. Thank you for the rose. And I'm more than sure I'm gonna pronounce this incorrectly. Quispe. Thank you for the rose, and I'm sorry if I pronounce that incorrectly. So, if f of x is continuous at a, then the limit as x approaches a of f of x is equal to f of a. So, this is called the way that I use this is called direct substitution. So what I do is I'm going to plug in a for x and c if it gives me an actual value. If it does, then we're done. But sometimes we'll have to do some algebraic gymnastics. So second one is that if I have the limit as x approaches a of some number k times f of x, where k is a number, then what I can do is I can take that k and I can move it out front. So that's going to equal k times the limit as x approaches a of f of x. So from here, let's go ahead and do number 3. Number 3 says if I have a limit as x approaches a I'm just making sure I don't forget any, because knowing me, I am going to. There we go. Okay. So, thank you for sharing the live. Apologize that I can't pronounce your, that I'm not sure what to call you. It looks like 2 people holding hands, so, but I could be wrong on that. So let's say I have 2 functions being added together, or I'll add a minus there. If that's the case, then what I can do, the limit of this, and I'll put this in brackets. So this is going to equal the limit as x approaches a of f of x. You're probably going to touch on it, but can you breeze over what it means when there's a plus or minus above a? I'm sure there's more to that question. Oh, are you talking about here? Okay, cool. Yeah, I'll get to that in just a moment. Yeah, no problem. So here, if I have the sum or difference of, if I'm taking the sum or difference of 2 functions and I'm taking its limit, then I can split it up into 2 different limits. And then 4 is going to be limit as x approaches a of f of x times g of x. Well, just like up here, the limit of a product is equal to the product of the limits. So limit x approaching a of f of x times the limit as x approaches a of g of x. And then I can do the same thing if I'm dividing 2 functions. Limit as x approaches a of f of x over g of x. And I'm putting brackets around these because I want to make it known that I'm taking the limit of the whole thing, not just one piece of it. Thank you, Gert, for the follow. So this is going to equal the limit as x approaches a of f of x divided by the limit as x approaches a of g of x. Now, we have to be careful here. Why? Because remember, the biggest rule in one of the biggest rules in math is that we can never divide by 0. So neither g of x can be 0, nor can its limit as x approaches a certain point be 0. Otherwise, it's undefined. So you read the limit approaching... Yeah, that's absolutely right, Nick. So here, if I have limit as x approaches a with a negative sign up here, it means that we are approaching from the left. Another way that I like to think of it as is this. Look at values less than a. Thank you, user, for the follow. And then, if I have limit as x approaches a from the right of f of x, it means that we're approaching... I should probably mention this is f of x from left side, from left of a. Approaching f of x from the right of a. Or look at values greater than a. Does that help, TikToker? Yeah, it is really cool, isn't it? How about the limit as x approaches infinity? Yep, we are definitely going to get there tonight, Christian. We are going to get there indeed. No problem, TikToker. Happy to help. So now, I'm just going to quickly check to see if I've missed any. I don't want to. Yeah. Cool. All right. Let's start. You love calculus? I love it too. Yeah, calculus gives me trauma. Sorry to hear that. Thank you, TikToker, for the follow. So, let's go ahead and try a couple exercises. BC is going to be difficult. It's going to be fast. The AP classes tend to go fast. But yeah, it will be a little more difficult, but like that, as long as your algebra and trig are solid, as long as your foundations in algebra and trig are solid, you should be fine. Yeah, that's the thing. That's okay. School started up here today, so a lot of students are. Thank you, Nazrin, for the follow. Yeah, so a lot of students like that. It's gonna be for like the first week or two. But that's why when I used to teach, I used to spend the first couple weeks just doing review. Thank you, Z0693, for the follow. All right, so now let's go ahead and try a few exercises. So, and actually what I'll do is for the first page, hey, Doll World, how's it going? Welcome on in. So let's try a few exercises. So here, I want to find the limit as x approaches 3. I'm glad it's going well. Of 4x plus 3. And I want to know what that equals. Well, let's go over to our rules and see what we can do. So here, I see that I'm adding two things together. So what I can do is I can break it up into two separate limits. So we have the limit as x approaches 3 of 4x plus the limit as x approaches 3 of 3. So the limit as x approaches 3 of 4x, now this is a linear function, and linear functions are continuous everywhere unless they're in like a weird piecewise function where at one point we just move the point up. But assuming that we're not going to run into that tonight, so what we're going to do is I'm going to plug in 3 to x. So I have the limit as x approaches 3 of 4x. So that's going to be 4 times 3 is 12. And then the limit as x approaches 3 of 3. So I knew I forgot one. That's okay. So the limit as x approaches a of some constant c is just going to be c. Do we agree that 3 is a constant? By that I mean, do we agree that there are no x's next to 3? Yeah, perfect. So, because of this rule, I can say that the limit as x approaches 3 of 3, well, 3 is a constant, and it says here, limit as x approaches a of a constant is that constant, so this must be 3. And finally, now that I have evaluated this limit, I now need to add these two together, and that will give me 15. Let's try another one. Let's find the limit as x approaches 7 of 5x minus 2. Can I do some infinity limits? Yep, I have those planned for later on. But yes, we will do some limits at infinity. TikToker says 33. Doll World says 33. Brian says, what's the formula, please? Okay, so here we are just following these rules. If you want to take a moment and take a screenshot of them, by all means, go for it. I'll give you a moment to do that, if you want to. Cool. Yeah, so following these rules, what I can do is I can go ahead and plug in, or sometimes you think the formulas look more confusing. Yeah, I agree. And a lot of the time the problems are gonna look a lot scarier than they actually are. Hey FA, how's it going? Welcome on in. So here I can plug in 7 here, or I can break it up like I did up here. But this is a linear function, so it's continuous everywhere. Again, we're not going to run into problems, at least right now, where we have wild and crazy piecewise functions where we have a linear function, but at a random point we just move the y value. So here, thank you Nicholas for the follow. So here I can plug in 7 for x. I almost said 5 for x. So I have 5 times 7 minus 2. 5 times 7 is 35. And 35 minus 2 gives me 33. So you are absolutely right. If a patient is having a heart attack, how can I use this stuff? Well, hopefully, if someone you know is, I'm not a doctor, so I don't know how to treat heart attacks, but hopefully, someone is ready. Hopefully, we're ready to do CPR. Please don't answer that guy. Don't waste your time. There's that light bulb, Brian. Let's go. So yeah. So here, the first rule of limits is if you can sub in, always sub in. So the only times when you'll have to do algebraic gymnastics or stuff is when you have stuff that results, in indeterminate form. So that's your 0 over zeros, your infinity over infinities. Do you think we could do more difficult algebraic manipulations with limits? I got an AP Calc test tomorrow. Yeah, right now for these first few, I want to get people. I want to do easier ones as a warm up before we get into those. You're tired of calculus? Okay, fair enough. Thank you, Goat. I appreciate you too. I appreciate you all for being here tonight and watching and spending your Wednesday evenings watching me do calculus and joining me doing calculus. Because you all can do calculus, I think. I know you can all do calculus. Your love for calculus is infinite. Fair enough. Thank you, love, care, and respect for the follow. And thank you, Goat, for sharing the live. So here, let's ramp up the difficulty a little bit. You've a man. Thank you, Luli. Thank you so much for that. Calculus is fun, indeed. So, let's go ahead and ramp up the difficulty a little bit. You just started your first week of Calc 1? Okay, how's it going, Patricio? So, let's go ahead, because I think you all got this. So let's do one like this. So, calculus, what's the fun in function? Awesome. You've done till Calc 3? That's cool. That is really cool. Thank you, Carlos, for the follow. So I want the limit as x approaches 2. Thank you, Goat, for the follow. Hey, what time do you start your streams? These are very helpful for me and I want to watch more. Sure, so I start my streams every night at 11:30 p.m. Eastern. I don't quite know what time it is where you are, but it's 11:30 p.m. Eastern. Thank you, Blank, for the follow. I used to be tutor for Cal in physics. That's awesome. That's really cool. Thank you, Monchito, for sharing the live. Wow. The history of calculus is my favorite history, to be honest. Very interesting. You're Eastern too, so it's good. Perfect. In ordinary differential equations, Calc 4, that's where I'm at. Cool. That's really cool, Steve. I haven't taken ordinary differential equations in years. Am I a professor? Nope. I am not. I used to teach, but I left the classroom back in 2018. Because I found that it wasn't for me. But I do like tutoring. So that is what I am. Over x cubed plus 4. So now we have one where I have a quotient. So what I'm going to do is I'm going to look at my rules, and I see down here that if I have the limit as x approaches a value of two functions being being divided by each other, I can simply take the limit of the top and the bottom and divide them by each other. So I have limit as x approaches 2 of my numerator, which is this. So that's going to be 2x squared minus 3x plus 1 divided by the limit as x approaches 2 of x cubed plus 4. So now from here, TikToker says 3/8. Let's see if you're right. So from here, this is a quadratic, and quadratics are continuous everywhere. As is down here. However, remember that this limit cannot equal 0. So let's take the limit of the top. This one has no bounds, but this one cannot equal 0. If it equals 0, then we're going to be in a different place than we want to be. So let's see what happens. So I'm going to plug in 2 everywhere I see an x. So I have 2 times 2 squared minus 3 times 2 plus 1. 2 squared is 4, and 4 times 2 is 8. 3 minus 2 is 6 plus 1. 8 minus 6 is 2. 2 plus 1 is 3. So up here, it's going to be 3. On the bottom, I'm going to plug in 2 everywhere I see an x. Oh, and this is x cubed. I apologize for not making that a little clearer. So here, I have 2 all cubed plus 4. 2 cubed is 2 times 2 times 2. 2 times 2 is 4. 2 times 4 is 8. 8 plus 4 is 12. So I have 3 over 12, which simplifies to 1 over 4. So that is our answer. That's okay. To be fair, I didn't exactly make that clear that was cubed. So I apologize for that, TikToker. Thank you, Monkey Man. I'm really happy to hear that. Thank you for that. You're all amazing for joining me and continuing to watch and get involved in the chat, because let me tell you, it's a lot more fun talking to you all in the chat versus me talking to a brick wall. Thank you, Christian, for the follow. Do you always try substituting in before you try any of the other limit laws that may apply? Yeah, I do. In fact, my rule of thumb is if you can always try subbing after you get at the beginning of the problem, and any time you manipulate the problem in any way. What math? You're welcome, Christian. What math is this? This is calculus. Can you show how to get greatest common factor? I can do a problem like this where we have greatest common factor. Sure. So like I said, I'm going to do a few of these, and then we're going to see what happens when x approaches infinity and negative infinity. Or actually, no, let's try one more like that, and then we'll get into different ways to factor. It seems more reasonable to do it that way, but my professor always wants us to apply a law. Okay, so if your professor says apply a law, apply a law. But and in fact, I've seen people get marked incorrect because they didn't use because they didn't follow the directions to a T. Oh, really? Never took calculus before, but this doesn't seem too bad. Thank you, kind sir. You're welcome, Jacob. Yeah, calculus isn't really horrible. It's involved, but not horrible. And the thing is, the other thing about calculus is that a lot of the times the problems look a lot scarier than they actually are. Thank you, Bubble Blowing, for the follow. We just learned the squeeze theorem today in my calculus class. This is just where we are. Perfect. Do I know formula for marginal revenue and marginal cost? I do. I can't remember them off the top of my head right this moment. Awesome to see more examples. It is indeed, and we have plenty more to go. Thank you, Glasswall, for the follow. Are there ever problems where you need to find the plug-in, and if, say, it is the same way but reverse? I'm not quite... So, are you talking about this number down here? Yeah? I've never seen it. I've never seen a problem where you're given a limit and a function, you have to find what's approaching. I mean, could they exist? Sure. But I've never seen it. But good question, Jacob. Very good questions. And please, if anybody in the chat has a question, please feel free to ask. If I may not know it, but I will definitely try and answer it. But yeah, so let's go ahead and try one more like this. Actually, yeah, let's try one more like this, and then we'll move on to a couple different exercises. What state am I from? You have an accent somewhere on the East Coast. Yep, I'm on the East Coast. I'm from Maine. I tell a lot of people I'm from Boston, but that's only because sometimes people don't know that Maine is a state. In fact, I've been asked before if I'm American because I'm in Maine, because some people think I'm in Canada, but I'm not. I promise you, I'm not in Canada. Awesome. That's really cool, Patricio. So yeah, so let's try one more like that. And then I think it will be time to turn the page. So limit as x approaches 4 of the following function. Let's have x squared plus 5x plus 6 all over x plus 4. You should go over IVT. Believe it or not, Lowell, Bina, I actually just went over IVT. I think it was last night. Let me check. Yep. We actually did IVT last night. All right. Do x approaching -4 to make it more challenging. Right now I want to we're going to do a problem like that in a moment. But for now, I want to try one more problem to without any division by 0. Hey, any algebra today, rings and fields? Nothing that I can think of. I used to love math. I'm sorry to hear that. Do you still? What? I'm sorry to hear that you don't like math anymore, PvP, or that you don't love math. But like I said, my goal with these lives is to have you like math, even if it's just a tiny % more. Because if that's the case, then I've done my job. Hey, so I want to know the directional derivative of that function. So tonight, I am working on limit laws, but if you want, I will put directional derivatives on the list. So let me do that. Direction derivatives. Can you try out the limit of f of x over x minus 1 as it approaches 1 equals 10? I have to find f of x and got 0. Okay. Yeah, I might be able to do that one. You'll just have to remind me to do that problem in a little bit. Have you shown limit tables recently? Let me check. I believe I have, but I'm not exactly sure. I don't think I've done it this week, though. Yeah, we did one here. But I haven't gone over them as a whole yet. Am I Scottish? Nope. Nope. Born and raised in America. Do you do Calculus 3 and differential equations or just Calc 1? So I tutor Calc 3 and differential equations, but right now, for tonight, or for a little bit, we're going to stick with Calculus 1. Yes, please do direction derivatives. I struggle with them a bit. Okay. Yeah, definitely. And also, I plan tomorrow to have a few videos up on my YT channel. So, if you go here after the live, if you go here and go to this channel, this is mine. Thank you, Anfrax, for the follow. Thank you, Admiral, for the follow. Okay, on to this problem. So, here is what I'm going to do. So first, my first step, I could use this rule here to work on my derivative, or to work on my limit. So I'm going to go, so the limit of a quotient is equal to the quotient of the limit. Thank you, T-Mac. Thank you for that. Thank you, Deo, for the follow. So here, I'm going to choose to do that. So I have limit as x approaches 4. I'll put my answer over here. So I have x squared plus 5x plus 6 all over the limit as x approaches 4 of x plus 4. So now, let's take the limit as x approaches 4 of that top function. So what I'm going to do is I'm going to take 4 and I'm going to plug it in everywhere I see an x. So I have 4 squared plus 5 times 4 plus 6. 4 squared gives me 16. 5 times 4 is 20. 16 plus 20 is 36. 36 plus 6 is 42. That's right, Patricio. You're right. And then, if I plug in my limit down here, what would the limit be as x approaches 4 of x plus 4 be? What would this bottom limit be? Remember that we have to avoid division by 0. So if it's 0, then we're going to have a problem. Patricio says 8. Hefe says 24 on over 4. I'm going to assume I think that you're looking for the final answer. User says 8. Christian, and then take da. Thank you, Richard, for the follow. Yes, you're a little bit ahead of me. Derivative of both. So that's called L'Hopital's rule, and L'Hopital's rule has a certain condition that needs to be met, namely that I need to have something in my function as x approaches 4 needs to cause indeterminate form. Since that doesn't happen here, we cannot use L'Hopital. Yeah, so this is going to be 8. So this is going to be 42 over 8. And 42 and 8 simplify to 21 over 4. That is right. What do you do if there's a 0 on the bottom? No problem, Omar. We're just about to get there. 42 over 8 or 5.25. Yep, that's right, Doll World. If you want to, I personally like to leave my answers in fraction form. But if you want to leave it in decimal, by all means. Would I have to rationalize? Nope, not here. There are some where I'll have to rationalize, or what we call multiply by the conjugate, but here I don't have to rationalize since I don't have a square root anywhere. Thank you, Omar, for the follow. Thank you, Marvely, for the follow. That's right, you can't use L'Hopital because L'Hopital requires that both this and this, or both this and this be 0, or infinity, or... Right, yes. Unless we have that, we cannot use L'Hopital. Alright. Can you teach how to find prime derivatives? Yeah, I think I'm actually going over that Friday. Let's see. This is too hard. That's okay. I'm sorry to hear that you think you're struggling with it. What questions do you have, Bob? Thank you, Longkey, for the follow, and thank you, Leo, for the follow. I apologize if I pronounce that incorrectly. Thank you, Omar, for sharing. Plug in first, and if something bad happens... Yes, absolutely. Always try to plug in first, and if there's something bad that happens, like division by 0, then we try the algebraic gymnastics. Can you do one small example today, please? I have my first test Friday. If I can't do anything like rationalizing and you have a value over 0, when do you try to find? Do you just plug in... I assume there's more to that question. If I have time at the end, I may do one. But tonight, I really want to focus on these two topics. Can I do another question? Absolutely. If you can't do anything like rationalizing and you have a value over 0, when do you try to find the what? I assume there's more to that question. Do you just plug in the limit? Yeah, most of it. So, like I said, always start by plugging in, and if it causes something mathematically wrong to happen, then we have to work on it more involved. I'm so mad. That's okay. That is perfectly okay. No problem. With a substitution rule, pretty much. Can you show us average velocities? So average velocity is not going to probably be tonight. Then you can find the equation of a tangent line of the denominator and use that approximation. Oh, so that connects. If you can't do anything like rationalizing and you have a value of 0, when do you try to find the limit? Then can you find the equation of the tangent line of the denominator and use that approximation? Approximate a tangent line equation to find the limit. Remember these days, this guy seems like a tutor I would have enjoyed. Thank you, Evan. I'm really happy to hear that. Is this for finding limits analytically? Yes. So, approximated tangent line equation. if you're talking about the derivative, there are certain rules that we would have. Like if I had, say, 15 over 0. Like if my limit ended up with 15 over 0. If there's nothing, if I've exhausted all my algebraic tricks to try and find that limit, then we say that the limit does not exist. Or if I've tried all of my tricks to get this to be a number not over 0 and it still is over 0, then the limit doesn't exist. What time do you usually get on to do live streaming? So I go live at around 11:30 Eastern time. Like how e to the x minus 1 behaves like x. Wait, if it is under 0, what is it known as again? So if I have 0 divided by anything other than 0, then it's 0. If I have 0 underneath my fraction bar, this does not exist. This is division by 0. But if I have 0 over 0, this is called indeterminate form. Let's do some delta epsilon limits. Yeah, probably not tonight. What I don't understand with all of the equations in business using the derivative, how are the formulas created? I don't actually know, I haven't actually taught, business calculus before. Thank you, Vin, for sharing the live. Oh, okay, thank you. I just learned this on my lecture, just needed. Awesome. You're welcome, Patricio. Can we do epsilon delta? Like I said, probably not tonight. Epsilon delta. I would need to do some preparation for epsilon delta. It's not that I can't do it. It's just that I would need more. I would need like 5 or 6 problems right in front of me, and I would need to go into the definition of epsilon delta. Yeah, no problem. I'll add it to the list though. I have a list. Please do one prime derivative question. Please, I beg, I need to go. Can you do fundamental theorem of calculus? Adding that to the list. Probably not tonight. There, go to. Is this all like early Calc 1? Yep, this is like the first couple of weeks of Calc 1. Thank you, Hank Barrett, for the follow. I'm going to take the Praxis test, the Praxis math test, and new. Math is fun, but it has to be practical to solve some realistic problem. If not, it's all just fantasy. But that's the thing. Mathematics, it's funny because what we discover as purely theory eventually has some application to math. For example, when we talk about the number I, for a while it was theory, but then we discovered we could use it in electrical engineering. Now, I'm no electrical engineer, nor do I know the formulas that they use for electrical engineering. L'Hopital's rule is hella practical. It is, but again, L'Hopital has a condition that needs to be met. Abstract explanations are so hard for me to understand until it's okay, fair enough. Like that tonight, like that limits do have application to it. I just can't think of any off the top of my head. But you can do optimization questions to teach practically. I have optimization on my list, but optimization would require that we know derivatives, which we're going to do on Friday. Or at least that's the plan. Oh. Oh. I'm using a lot of algebra and commercial real estate finance to solve for variables. Okay. What math is this? This is calculus, Jim. This is calculus. And that's all we're doing right now. We're just taking a number and plugging it in. At least for right now. Starting with the next problem, we're going to amp up the difficulty a little bit more. So I'll do a couple problems like this one. You're taking AP Pre-Calc. Is there anything I should know? AP Pre-Calc is a really new class that I'm still... I can tutor it, but I'm still trying to figure out the ropes of AP Pre-Calc. Because AP Pre-Calc didn't exist when I was taking the AP classes. In fact, I think AP Pre-Calc started, what, 3 years ago? Pre-Calc was harder and... Yeah, I could see that. Yeah, it's a bit weird. It's a combination of lots of algebra 2 and geometry. I have the limits and continuity test tomorrow, and I'm getting up at 5 a.m. to study again. Okay. Good luck, Alec. The thing is, though, just be sure not to, do too much studying, because believe it or not, there is such a thing as too much studying, because at some point, there's this thing called the law of diminishing returns. So, eventually at some point, you study so much that you just start to lose all the information, that you're learning, because as your study time goes up, even when I do math, the longer I do math, the more tired I get, and the more tired I get, the more mistakes I make. I would like to use calculus to optimize my revenue and minimize my costs, but I was never taught how. Okay. Yeah, I should be doing optimization here, and I think if I do it right, I should be doing optimization sometime next week. Can you explain Calc AB and Calc BC and how they compare? Sure. So everything in Calc AB is in Calc BC, but not everything in Calc BC is in Calc AB. So Calc BC takes everything from Calc AB plus series and sequences. That's the main thing. Thanks also explaining IBTs is the hardest part, and the problems with X approaches infinity. No problem. And we're going to be doing an integration by parts. You're right, Hefe. I forgot about that. Thank you, Seni, for the follow. And partial fractions, yes. So let's see what we get. So I saw a few of you already try to solve that problem. So let's go ahead and work on it. So what if I plug in 3 here, what do I end up getting by plugging in 3? Well, 3 squared is 0. So if I apply my limit laws, let's apply those and see what happens. Plugging in 3 for x, I get 3 squared is 9. Negative 4 times 3 is negative 12. 9 minus 12 is negative 3. Negative 3 plus 3 gives me 0. And 3 minus 3 is also 0. Right, so we can't have a 0 on the bottom. Yeah, so what do? Well, this is the first skill that we can do, is to try factoring. So let's go ahead and plug and try and factor the numerator. I can't factor the denominator. Yes, I could use L'Hopital, but I'm not going to, mostly because it's not always going to work. Thank you, David, for follow. So, but the tricky part they never taught is in managerial economics is how to derive a revenue function. Okay. Yeah, I've actually never taken managerial economics, so I'm not quite sure what's in that class. Or the cost function. Yeah. So, I can factor this top part. So I have two numbers, multiply to 3 and add to -4. Right, Irving, that would be x equals x minus 3 and x minus 1. So limit, as x approaches 3, of x minus 3 over x minus 1 all over x minus 3. I agree. And if you want to do L'Hopital, you can. But here I'm just choosing not to. So now I have an x minus 3 on top and an x minus 3 in the bottom. So remember from algebra that I can't just cancel an x and an x and a 3. However, what I can do is I can rewrite x minus 3 as 1 times x minus 3. So now I'm multiplying, and because I'm multiplying, I can cancel my x minus 3's. Yes, it does, Christian. Absolutely it does. So here, now, instead of having the limit as x approaches 3 of all of this, well, also, anything divided by 1 is itself. So we can say bye to all of those things. So I have limit as x approaches 3 of x minus 1, which is simply 3 minus 1, and 3 minus 1 is 2. Thank you, Nathan, for sharing the live. You can also use L'Hopital's rule. Yeah, you can. And in fact, it would work here because you have this 0 over 0. But as I said, sometimes we're not always able to use L'Hopital. So we have to know how to do this in case we ever run into that situation. Why is it 3 minus 1? Sure. So once I get to this point, I no longer have to worry about division by 0 or anything that's going to break any math rules. So what I do is I follow rule 1. I now have limit as x approaches a of f of x. Well, f of x is going to be, now that I have cleaned that up, I can just plug in a everywhere I see an x. If you haven't learned derivatives yet, sometimes factoring is easier. Absolutely. And that's the thing. L'Hopital's rule requires knowledge of derivatives. And I'm assuming, and I like to assume, that we don't know how to do derivatives quite yet. Yo, can you do integrals, please? I already have some parts of integration on my list. In fact, here is my list. And I'm happy to add anything onto that. So you factor the function if the denominator is 0 always, right? Well, it depends on the situation. Sometimes factoring won't work, but sometimes we'll have other tools that we can use to solve the answers, to find these answers. Limits on their own have very few, if any, real-world uses, but calculus is built. Thank you, Big J, for sharing the live. What math is this? This is calculus. This is calculus 1. What was I going to do? Oh. I was going to look up the real life use of yeah, so there are a few different, there are real world uses of limits, but there are very few problems that I'll be able to give you that actually have that use. Use L'Hopital again. I could, yes, could I use L'Hopital here? Absolutely, I could. But remember, I'm assuming right now that not everyone here knows how to take a derivative. And that's what L'Hopital's rule would involve. But yes, if you want to use L'Hopital here, it will give you the same. It'll give you the same exact answer. So yes, you're right. Thanks for the heads up. No problem. Thank you, Paco, for the follow. So let's try another one like this, and then we will go into, or we'll try a couple more problems, and then we'll get into limits at involving infinity. Limits at infinity, because I want to go over that too tonight. So. Ooh, I like that one. So limit as x approaches 3. And I'll do 3 again. So I have x squared minus 3x all over 2x squared minus 5x minus 3. Thank you, Trades, for sharing the live. Yep, this is calculus. Could you... Oh, yes, you're right. Yeah, you're right. I almost forgot about that problem. Redo everything, please. Well, I'm already an hour into it. If you wanted to get out of here, I'm not sure why you clicked on this live. I took calculus in college, but forgot a lot of this. Seems interesting, but I'm motivated by math. Okay, yeah, that's math that you can use as a tool. Okay, yeah, and there's plenty of math that you can use. Do some with trig identities. You're taking calculus 1 right now. That's cool, Playboy. I'm taking Calc AP in high school. That's cool, Danny. Cal AB or BC? You like trig? Awesome. AB, awesome. That's really cool. Do some with trig identities? We might do some later. I don't have any prepared tonight, but could you try limit of f of x over x minus 1 as x approaches 1 equals 10? Yeah, I can do that. I will do that one. Thank you, Will, for the follow. Thank you, Period, for the follow. What should you start learning to feel confident in it? How is your algebra... On a scale of 1 to 10, how did you do in algebra and trig? Just remember SOHCAHTOA? Yep. First day in calc, you are lost. I'm sorry to hear that, Alexander. Thank you, Spare Me, for the follow. So here, I'm going to go ahead and start by plugging in 3 and see what I get. So I get 3 squared is 9, and 9 minus 3 times 3 times 3 is 9. 9 minus 9 is 0. And 2 times 3 squared. 3 squared is 9, times 2 is 18. 18 minus 5 times 3, that's 15. 18 minus 15 is 3. And 3 minus 3 is also 0. So I get 0 over 0. That's not allowed. So yes, I could use... So I'm going to say that, yes, I could use L'Hopital here since it meets that condition. And as I said, if you want to use L'Hopital here, go for it. But I'm going to go ahead and factor this. So I have limit as x approaches 3 of the following. On top, what can I factor out? Well, I have an x squared and a minus 3x. Greatest common factor is x, yeah. And what I'd be left is x minus 3. Very good. On the bottom, what would that factor to? Thank you, Jimmy, for the follow. Just like I said before, yes, I could use L'Hopital here, and like I said, if you want to use L'Hopital there, go for it. I'm just choosing not to. For the bottom, 2x plus 1 and x minus 3. Let's see, so 2x times x is 2x squared. 2x times 1 is 2x plus... You said 2x plus 1 and x minus 3. So that's going to be 2x squared minus 6x plus 1x. That's negative 5. Yeah, you're right. So, here, I now have an x minus 3 and an x minus 3. So I'm going to go ahead and cancel those. And I'm left with a limit as x approaches 3 of x divided by 2x plus 1. Now here, I can go ahead and plug in 3 everywhere I see an x. So I have x is 3. 2 times 3 is 6. 6 plus 1 is 7. So my answer is 3 over 7. Is this continuity? No, this is limits. I'm sorry to hear about you having a headache. Have a good night, Christian. No problem. Thank you, Sai Hodge, for the follow. And I apologize if I pronounce that incorrectly. And also, thank you, Niola, for the follow. If I pronounce that incorrectly, I apologize. Thank you, user, for the follow. Do I make YouTube yeah, I do. Well, I need to do better. I used to, and I need to do better at making more videos over there. But this is where you can find me over there. Can you go over epsilon and delta rules? Epsilon delta is actually on my list of topics to go over, but I'm not going to go over it tonight. Thank you, Maricela, for the follow. And again, I apologize if I pronounce that incorrectly. Thank you, Alexander, for the follow. Already very cool. We did proofs of the volume formulas and cylinders. Yeah, I think it's pretty cool. You're learning limits right now? Awesome. Is this limit continuity? This is solving limits. Thank you, Youssef, for the follow. Thank you, Carson, for sharing the live. Can you solve the same problem using L'Hopital's rule? Yeah, you could. You would simply take the derivative of the top and of the bottom. What is L'Hopital's rule? Okay, I'll show you what L'Hopital's rule is. So, suppose I have a limit as x approaches a of f of x over g of x, and the result gives me 0 over 0. If this happens, then we say that the limit as x approaches a of f of x over g of x is equal to the limit as x approaches a of the derivative of f over the derivative of g. Is this Calc 1? Yep, this is Calc 1. They won't teach you L'Hopital until towards the end or middle of Calc. Yeah. So, thank you, Bryant, for the follow. can you do limits with sine and cosine, limits with trig, please? I do have a problem that I need to finish first. And it has to do with this, so I've been meaning to do it for a while. Let me see if I can find it. Oh, there it is. So, Mr. 705, if you're still here, is this the problem that you're referencing? Limit as x approaches 1, f of x over x minus 1 equals 10. Awesome. So, wait, how do you find the derivative again? I'm actually going over that on Friday. Thank you, V, for sharing the live. Radical function was my warm-up in calculus for the first day, and can you please explain? I was lost. I'll do a radical function one after this, yeah. And so, yep, L'Hopital is a useful shortcut, yep. Is Calc 1 the same in college as in high school? Not really. Or it is, but Calculus 1 in college I found to be more formal than the first semester of AP Calculus. How many years of math does it take to get up to this level? So they teach this. So they teach calculus as AP in high school, or you can take this in college. Alright, so here we're asked to find f of x. So here, if I plug in 1, I get something divided by 0. But derivative of x squared is just 2x? Yep, that's right. So here, I need to find f of x. So what I need to do is, ideally, I need to find a function that I can use to cancel out this x minus 1. So what I'm going to do is I'm going to go ahead, because I don't know what f of x is, I can write a function that involves f of x. So let f of x equal something g of x times x minus 1. So I'm going to let f of x equal some function g of x times x minus 1. Then, limit as x approaches 1 of g of x times x minus 1 all over x minus 1 equals 10. I haven't done anything. Oh, sorry. So yeah. So I'm giving f of x a definition, and that is g of x times x minus 1. And all I've done here is just plug in this for f of x. So, here, is Cal 1 really hard? I'm taking it in college right now. Nope, I wouldn't. Or I'll put it this way. On a scale of 1 to 10, how solid is your algebra and trig foundation? So from here, just like before, I can cancel that x minus 1. And so the limit as x approaches 1 of g of x equals 10. So from here, I could let g of x be anything so long as it equals 10. I'll give you a couple of examples. G of x could equal x plus 9. Or g of x could equal, I don't know, x squared or plus 6x plus 3. There are a ton of functions that this there are a bunch of functions that g of x could be, but yeah, you could do 11 minus x, sure. Thank you, Gordon, for the follow. But yeah, so any one of these functions, among others, will get you that limit to be true. I'm really good with algebra and factoring stuff, but I don't understand in class. And you help me, please. Yeah. I can help you with that. Or you can have 10. That works too. You can definitely do that as well. But that's how you would solve a problem like that, Mr. 705, if you're... Just redefine your function and let the algebra do the work. Alright, let's see why I do that. Why, if I missed a problem. That's okay. That is perfectly fine. Okay, thank you. I think I got that wrong for my homework. Okay. Well, if you see a problem like that again, so basically define a function that allows... Yes, that's how I would solve a problem at least. But again, I personally have not assigned a problem like this before. So that would be my best attempt at solving that problem. Alright, cool. How did I get x plus 8? Here? That's a 9. X plus 9, sure. So here, remember that once I have a function and I don't have to do any more simplification, I can just plug in my value over here in for x. So here, g of x could be x plus 9, or it could be this, or it could be this, or it could be a whole host of functions. These are just 3 that it could be. Yeah, no problem. Okay, let's do one where we have to, what's the answer? There are multiple answers. In fact, there are theoretically infinite. Yes, so these 3 are just these are 3 possible answers. Can you explain the chain rule for me, because I'm taking Calc BC and as the right circle? No problem. I'm actually going to be going over that on Friday when I talk about the derivative rules. The 4 basic derivative rules. That's what I'll be talking about on Friday. So yeah, I do want to get to a radical problem, and then I want to also get to limits at infinity. Do I also teach statistics? I do. I've gone live a couple of times doing stats, and I'm gonna try doing that as well. I'm gonna try and finish that list, and then can you leave the answer as 10? Yeah, you can leave this at 10 if you want, because the limit at x approaches a number of a number is just this number. In your honest opinion, do you consider stats real math? Absolutely. Absolutely, I do. Absolutely. I have no idea how I passed college because you were good at the classes that you took. This is called... Thank you, World. Thank you for that. Looking at this, I'm like, damn. Yes, really? I promise you, these problems look a lot scarier than they actually are. Can you accept my request, please? I want to talk. I have a few problems I have to get through tonight, so probably not. You can DM me if you like. More example, please. Coming right up. So, let me go ahead. Let's do one with a radical this time. So let's do limit as x approaches -1 of the following. I want to make sure. Did I leave myself enough room? I hope so. I don't think I did, though. Over x plus 1. I think I wrote my fraction bar a little too long. That's okay. We'll make it work. Can you find the limit as x goes to negative 3 pi of f of x equals... Yes, Andrew, that is exactly where I'm going to be going. Where do I submit my problem? You can DM me if you like. I'll probably be more willing to answer questions outside of what I'm talking about on live on current lives if you DM me, because I usually when I do these guys, I usually like to stick to one topic at a time. But if you need a question answered, feel free to DM me, and I will. And I'm probably gonna, and I'll be more responsive to answer your individual questions. Thank you, Emily, for the follow. What does LIM mean? This just means the limit. So if we remember, thank you, World, for the follow. So this means that as x gets closer to a certain value a, what y value does f of x approach? So there we go. And I'm pretty sure I didn't leave myself enough room, but I'll deal with that problem in a minute. So if I plug in -1 for x, I get -1 plus 2. That's 1. The square root of 1 is 1. 1 minus 1 is 0. And -1 plus 1 is 0. So yes, again, I could use L'Hopital here, but I'm not going to. Instead, what I'm going to do, as a couple of you have mentioned, is I'm going to multiply by what's called the conjugate. So what is the conjugate? Well, the conjugate, if I have, say, x plus a, the conjugate of I just got invited to co-host a live. Huh. So if I have x plus a here, the conjugate says keep the terms, but switch the sign in between. So that would be x minus a. So what I'm going to do is I'm going to go ahead and multiply by the conjugate of the top. Why would I want to do that? Well, this is called difference of squares. So what would happen is I would get x squared minus a squared. Thank you, Isa, for the follow. So here, if I multiply the top by the conjugate, I'll do it this way. The square root of x plus 2 plus 1. Because remember, I keep my terms. I just change the sign between. And remember, though, what I do to the top, I have to do to the bottom. But instead of foiling the bottom, I'm just going to leave it as is. But I do want to foil the top using this. So what would this be? This would be the square root of x plus 2 all squared. So the square root and the square we can say bye to. And that would be x plus 2. -1 times +1 is -1. And that's going to be all over x plus 1 times the root of x plus 2 plus 1. So the reason I want to leave it like this is this. So limit as x approaches -1 of the following. So this is x plus 2 minus 1. 2 minus 1 is 1. And I'm left with x. Oh, this should be plus 1. There we go. I was going to say, I think I may have run into a mistake there. Nope. Just forgot my sign. So from here, all I need to do, I can once again say bye to my x plus 1s. And I'm left with limit as x approaches -1 of 1 over the square root of x plus 2 plus 1. And now I can plug in -1. So this is going to be 1 over -1 plus 2. -1 plus 2 gives me 1. 1 plus 1, 2. My answer is 1/2. Do I only stream at night? So far, yes. At least for now. Is this calc? This is indeed. This is indeed calculus. Why didn't I square a problem to get rid of the root? Because so if I did that, so remember I can't, if I'm adding or subtracting in the denominator, if I were to square this, I would still have a root. So what would happen here? So if I had x minus x plus 2 minus 1 all squared, that would give me what? That would give me x plus 2 minus 2 times the square root of x plus 2 plus 1. So I would still have a square root, and it would essentially accomplish nothing. Where did the 2 on top go? Here? Where did I get x plus 1 on the top? Yeah, so once I did this, I was left with, so remember, x squared minus a squared. Here's my x, here's my a. The square root of x plus 2 all squared is x plus 2, because the square and the square root cancel. And then, negative 1 times positive 1, that's going to give me negative 1. And then I have to combine my 2 and my 1. 2 minus 1 is 1. So that's why I get that x plus 1. So that is where I get my, I'm in Calc 2 and streaming study sesh sounds so cool. Yeah, perfect. But what if the root was on the bottom? Do you still conjugate? Yes, you do. Yes, you do. You're not dumb, Dream. Please don't think that. How do you FOIL without the box method? Years of practice. No, all you have to do is remember that you're essentially solving 4 multiplication problems. And once you do that, you just simplify. No problem, Sam. Can you do an infinite question? Yep, I was just about to get there next. You have a limits grade tomorrow, Visla. Thank you. I really appreciate that. Yeah, no problem, Cedric. Can you show how to write IVT theorem conclusions? Sure. We actually did IVT last night. So once you solve a problem, this is how I would write them. Therefore, by IVT, f of x has a, or in this case, we had to find the root. So we had to prove that there was a root here. So my conclusion was, therefore, by IVT, f of x has a root inside the interval. So I want to say by IVT, there's a value c in my interval such that f of c equals my value of choice. Thank you, that boy, for the follow. Is L'Hopital method easy to learn as a Calc 1 beginner? L'Hopital's rule involves this thing called a derivative. And the derivative, if you're just starting Calculus 1, you'll want to get the idea of a limit down first before we talk about derivatives. Is this easy? For me, yes, because I've done it for so long. For others, not so much. So, I'm going to do a couple problems where now we're going to talk about limits at infinity. That's a really bad infinity. Let me try again. There we go. That's better. What's the physics that we use a lot? I mean, what type of physics do we need for evolution? I'm not quite sure. I think, isn't evolution biology? Mostly biology? I mean, it's been a while since I took that, but I'm pretty sure evolution deals more with biology than it does physics. How would you study if you were starting Calc 1 all over again? What would I focus on? Yeah, no problem. So, So if I were to start over at Calc 1, and are we assuming that I forget all my knowledge of Calculus 1? Yeah, no problem, Chill 1. How do they determine X, Y, and XX chromosomes? Yeah, I haven't done biology in years. It's been a while. Usually, so the yeah. Moving on. Dream. Are we assuming that I forgot all my knowledge of Calc 1, or do I still have my knowledge? Yes, as if you have basic algebra but don't know. Okay, so basically we're saying, okay, I know everything up to Calc 1, but after Calc 1, suddenly I my brain just decides to flush out any knowledge of calculus. Okay. So if I didn't know my limits or derivatives, I would want to make sure that my algebra and trigonometry skills are solid. I just want to make sure I got the question. Oh, there it is. So really, I would focus on making sure that my um, algebra and trig are solid, because once if those two are solid, then the rest of calculus is just adding on to what I already know. But those are my two priorities. On a better question, what should your math knowledge be before taking Calc 1? So you should have a good solid grasp of your algebra skills, and you should also know your your trig identities, your Pythagorean identities would be a good thing to know too, because sometimes we're going to run into those. But you have pre-calc knowledge like the unit circle. Yep. So if I did well in pre-calc, then everything just would add upon it. So if I'm starting over, I want to start with limits, because the limits are going to show me how to take derivatives in the future. Good question. So, how to figure a tank that is 28.9 feet at overflow with 8 foot and a million gallons. Have I ever done math 1324? I'm not sure what that is. But let's go ahead and go into this. So let's say, so there are when we take limits at positive or negative infinity, we're really looking at what happens as we go as far as we can to the left or to the right. I'm curious what got you into math and why. Let me finish this first, and then I'll answer that question. But yes, I will answer that question, Chill One. I just want to get through this part first. So let's say, usually when we deal with limits as x approaches infinity, we're looking at a quotient. If it's not a quotient, let's say I have limit as x approaches infinity of x to the n, or as n approaches infinity. Yeah, let n be any variable, then this will equal infinity. Because infinity to any power, that's not going to really change infinity, but it's just going to determine how fast and quickly we get to infinity. So, I'm going to present you with three possibilities. So suppose I have, so possibility 1. So suppose I have limit as x approaches infinity of, say, x to the m over x to the n. And we know m is greater or is less than n. Then it becomes a question of, okay, which one of these grow faster? Well, if m is less than n, then this limit is going to equal 0. Why? Because I can remember my rule. Remember that x to the m over x to the n is equal to x to the m minus n. And also remember that x to the negative n is equal to 1 over x to the n. And as this gets closer and closer to infinity, I'm essentially only taking one slice out of an infinitely many times cut pie. So my pieces are going to be pretty much not even existent. I was just about to get there, Michael. I'm just getting there next. We were learning about radical functions and finding its natural domain and range. Yeah, that's a good thing to start with as well. So the second condition, thank you user for the follow, is suppose I have the limit as x approaches infinity. I'm going to keep my x to the m over x to the n, but this time m, I have to make sure I do this right, is greater. Thank you Bob Marley for the follow. And thank you Ariel for sharing the live. So if m is greater than n, then this is going to result as, this is just going to be x to the m minus n. So the limit as x approaches infinity of x to the m over x to the n would equal infinity. And then the third case is if they're equal to each other. If m equals n. If m equals n, then my x to the m minus n is going to be x to the 0. And remember that x to the 0 is equal to 1. So the limit as x approaches infinity, x to the m over x to the n is equal to 1. Well, in this case, it would be 1. But suppose I had like 2 up here and 3 down here, then it would be I would just be left with my coefficients. And that would be my answer. So knowing that, thank you, Alex, for sharing the live. Knowing that, let's try a few. Let's try a few. But first, there are 20 of us in here. Let's see if we can't get to 8K likes. Thank you, Yo Chill One, for the follow. Let's see if we can't get to 8K likes before we continue. But anyway, I believe there was a question on there about how I got. I'm curious what got you into math. Thank you for the tiny dream. And thank you for the rose as well, Dream. I don't know if you thank you, Raul, for sharing the live. I don't know if you just sent me that or if it's been up there, but if it's been up there, I apologize for not seeing it earlier. So I'm curious what got you into math and why. So that is a really good question. So I got into math because I was good at it as a child, and I found that I really enjoyed teaching people it and helping people out with math. So I've always been good at it, but I saw that others weren't, and like that, I said to myself, "Hey, I want to help people, so I want to use the gifts that I was given to do that." Now, does that mean that every math class I've ever walked to was easy? No. At some point, your natural talent has to be reaches a maximum, so you have to start work. Your natural talent ends up needing to be worked on. It's like players. It's like any sports player or any pro athlete. They have natural talent, but they also have to work at it too. Because we all have natural talents that we are good at, but we can't rest on our laurels and be complacent or arrogant. And trust me, I know what it's like to have those gifts and be arrogant. I learned really quick that's not how it's gonna roll. So let's try a couple. You all are awesome. So let's go ahead and try our first problem. We got you. Awesome. Yes, thank you for that. So let's try a few exercises. I didn't even notice. I apologize. Yes, I'm well more than 8K. So let's move on to some examples. Because math is everything if you think about it. We live in a three-dimensional world and every obstacle. Yeah. So limit as x approaches infinity of 6x squared minus 4x all over 7x squared plus 6x. So here, I'm going to show you a little trick that I like to do to solve these. So, what I'm going to do... Thank you, Hefziba, for the follow. I'm sorry if I pronounced that incorrectly. So here, I'm going to show you a little trick. So when I have a limit as x approaches infinity, what I'm going to do is I'm going to look for the highest exponent in the numerator and the highest exponent in the denominator. Do I have knowledge on chemistry? I'm really into chemistry, and I know that math is required as well. I haven't taken chemistry in almost 20 years. It has been a very long time. I almost failed chemistry, but I'm not sure if that was because of me or because my teacher had short-term memory loss. So here's what I'm going to do. I'm going to look on the numerator, and I'm going to look for my highest power. My highest power here is 2. So this says that as x approaches infinity, my x squared is going to grow a lot faster than my 4x. So we can just forget about that term. X approaches infinity of 6x squared. And then I'm going to do the same at the bottom. So I have 7x squared plus 6x. Again, my x squared is going to grow faster than my x. So at infinity, my 6x becomes negligible. So this would be 7x squared. So from here, I have 6x squared over 7x squared. So remember, let's go back to my limit laws for a moment. If I have a constant times f of x, I can move that constant out front. So, do we agree or disagree on the following? 6x squared over 7x squared, I can rewrite that as 6 over 7 times x squared over x squared. Thank you, Poncho, for sharing the live. Do we agree or disagree that this is the same thing? Pierre says agree. Chase says agree. Rio says yes. Yeah. Jacob says agree. Perfect. So yeah. So all I'm doing here is I'm just multiplying. So what I'm going to do is I'm going to take this 6 over 7 and I'm going to move it out front. So I have 6 over 7 times the limit as x approaches infinity of x squared over x squared. Now if I look at my... Yes, that's exactly right, Astral. I was just about to mention that. So here, I have x squared divided by x squared. So my exponents are equal. So that means we can say bye to those. And I'm left with 6 over 7 times the limit as x approaches infinity of 1. Remember, the limit as x approaches anything of a constant is just that constant. So this would be 6 over 7. And that's it. Thank you, Homelander, for the follow. Thank you for the follows. And that's it. Like that, that's just a little... There are books that say, thank you, Pierre, for the follow. I feel like I just walked into something. Seems way simple. Absolutely. There are books that will tell you, okay, find the highest exponent and divide everything from that exponent. But I figure, why would I do that? Sometimes taking the shortcut is the best way to go. Again, I didn't do it during any of the previous problems because I wanted to show that it wouldn't always work. But here, it works. Yeah. Sorry. Can we do another one? Absolutely. We will do another one. We will indeed. So the limit as x approaches infinity of the following. Let's do 3x cubed minus 6 all over 1 minus x squared. So here, again, I'm going to look for where my highest power of x is. And I'm going to essentially ignore everything else. So here, I have an x cubed, and remember that when I have a constant, it's constant equals constant times x to the 0. So I can rewrite negative 6 as 6x to the 0. But 0 is less than 3, so I can ignore that, right? Because 3x cubed is going to grow a lot faster than 6 as we get closer to infinity. So that's going to be 3x squared, or 3x cubed rather. There we go. And on the bottom, I have 1 minus x squared. So here, remember 1 is x to the 0, 1 times x to the 0, and this is x squared. x2 is greater than 0, so I can ignore everything else that doesn't have a square. So now I have 3x cubed over x squared. And now the power in my numerator is greater than the power in my denominator. So therefore, what would the limit be of that? Oh, it's negative. You're right. And that's the other thing we have to worry about too. Be careful what your sign is here. Is it positive infinity or negative infinity? Gloria says positive infinity. Doll World says negative infinity. Insta Thrifty says positive. So, is that a pumpkin? Anyway, they say negative infinity, so it looks like we have a bit of a we have a bit of a issue here. We have a bit of a debate here. So let's see which one is the right answer. So here, I'm going to go ahead and simplify that. Thank you, Niguez, for the follow. So here, I'm going to simplify that. So x cubed divided by x squared is the same as x to the 3 minus 2. So this would be the limit as x approaches infinity of 3x, but because the numerator is growing faster, it's positive. So believe it or not, it's actually negative infinity. Why? So here I would have 3x divided by negative 1. So this is the same as the limit as x approaches infinity of negative 3x. And just because we have positive infinity doesn't mean that when I multiply it by negative that it suddenly no longer becomes negative. So this would equal negative infinity. So we still have to watch our signs. If this were plus x squared, then absolutely it would be positive. Thank you, Cedric, for the follow. I took the derivative, right? Nope, I did not take the derivative. I didn't have to. These are so confusing to me. Okay, what questions do you have, user? What is a limit? Thank you, Storm, for the follow. For the share. Sorry about that. Why would it not be negative infinity squared on the denominator? So it would be if the negative were if it were inside parentheses. If I had negative x all squared, then it would be this would be positive 1. But because we have negative x squared, this operation tells us, okay, take x, square it, and make it negative. What math is this? This is calculus. Cool. I'm glad it makes sense, Gloria. Does anyone else have any questions? Feel free to ask, please. Questions are a good thing. Did you ignore the 6 and the 1 because they're negligible? Yep. So because x is approaching infinity, we're looking at only the values that are most impacted by infinity. Thank you, Urex, for the follow. What happened to the 3 squared? Are you talking about here? Can I make one with absolute value? I don't actually have one of those prepared. Thank you, Not Rachar, for the share. And thank you, Neil, for the follow. Oh, what happened here? So what happened here is this. So here, nothing changed from here to here. But what I did was remember this rule. So if I have x to the m divided by x to the n, it's equal to x to the m minus n. So what I did here was I did x cubed divided by x squared. And from there, 3 minus 2 gives me 1. And remember, a variable without an exponent means that we can assume that the exponent is 1. What happened to negative 6? Sure. So as x gets closer and closer to infinity, if you were to do this on a test, negligible number removal won't. It's not really negligible number removal. It's looking at the end behavior model of a function. So we're looking at essentially if this gets really big, we're looking at, okay, 3x cubed is gonna shoot higher and higher than negative 6. So this isn't necessarily looking at just removing numbers willy-nilly. This is just following end behavior model. So that's what happened to this -6. So because we're taking, as x gets higher and higher infinitely, this -6 just becomes kind of irrelevant. Same thing happens to that 1. Thank you, Gloria, for the follow. Thank you, Pinecone, for the follow. How high in math do you teach? So I actually tutor. Where did the list go? Here it is. I tutor everything on this list. Is this Calculus 1? Indeed it is. Thank you, user, for the follow. In class, we just do a line across, and if that works, go for it. Thank you, Society, for the follow. Statistics, please. Yeah, so I can is there any topic in statistics you want me to put on the list? Yeah, but you can't just take it out, right? Because you can't manipulate the original function. So the rules kind of change when we deal with infinity. OMG, no way our professor just went over this today. Awesome. Perfect timing then. Oh, gotcha. I'll definitely swing by for when you tutor differential equation. Thank you, Hydro, for the follow. Quantitative variable. Okay, I'll add that to the list. I need to get a bigger list. Quantitative variable. Thank you, Hydro, for the follow. Thank you, question mark, for the follow. Thank you, Omar, for the follow. Thank you, Heart, for the follow. What's the difference between Calc BC and Calc 1 and 2? So Calc BC covers everything that's in Calculus AB, but it also covers everything you'll find in Calc 2. Power series. I can add that to the list, sure. I was actually looking at some power series problems today. Question. I'm getting into statistics honors this year. Is this class hard? I'm not necessarily. Oh, thank you for the rose. Unfortunately, I can't speak. I don't know if that's Arabic or Hebrew, but I can't speak either of those, so I am not sure how to pronounce your name. So I apologize for that. But also, thank you, Diego, for the rose. So, let me go ahead and scroll down there. All right. Is this class hard? All right. Let me ask you a question. How are you on word problems? Thank you, Ernie, for the shares. Can you move straight into calculus after Algebra 2? I would not recommend that at all. You could, but I wouldn't recommend you do. Can you explain the limit example? We're working on limits now. Which limit example? You finished multivariable your freshman year of high school. You're taking multivariable calculus as a freshman in high school? That's actually impressive. That is really impressive. The one I have written down here. Yeah, I would take trigger pre-calc first. Okay, cool. So, yeah, so I can explain that. So here, we're taking the limit as x approaches infinity of this function. So what I do is I refer to this thing called end behavior model. End behavior model tells us what a function does as it gets really, really big, as it goes towards positive infinity and negative infinity. But here, I only care about positive infinity. So thank you KLIMN for the share. So I'm looking for what happens as this function gets really, really big in the positive direction. So here what I do is I use end behavior model. So what does end behavior model tell us? End behavior model tells us that the function in the numerator and the denominator act as if it were the the part of the function with the highest exponent. So 3x cubed minus 6, as x gets ridiculously large, is going to start to emulate 3x cubed. Likewise, 1 minus x squared, as x gets really ridiculously large, is going to emulate negative x squared. So that means that I can take the limit of highest power over highest power in the numerator over highest power in the denominator. So that's how I get 3x cubed over negative x squared. But remember that negative x squared, the negative is not in parentheses. It's only x being raised to that power. So from here, I just applied an algebra rule, an exponent rule that says if I have the same base being raised to two different powers divided by each other, I just subtract my exponents. So that's how I got from here to here. And then I remember that positive divided by negative gives me negative. So that's how I got there. And as x gets really large in the positive direction, I end up with negative times positive, which gives me negative infinity. Thank you, Annie, for the follow. Thank you, Limited, for the follow. Is there an actual math algorithm to win the lottery? If there is, I'm not sure, but if there is, please let me know. What's your favorite level of math? Calculus. I love calculus. It is really fun. Could we just use the power function to solve this, or would we have to simplify this first? Power function. That's a good question. I have to remind myself about the power function. I scored a 5 in AB and a 4 in BC in middle school shit. That's actually really impressive, user. That is really impressive. Yeah, I would do some stats. But then again, I don't know too many people who have scored a 5 who score a 5 in AB and 4 in BC in middle school. That's my question. How are you doing that? How are you even allowed to do that? Thank you, Isaiah, for the follow. Advanced factors, please, examples. I'm not quite sure what that means, Bambino. Thank you, Zia, for sharing the live. Yeah, I'm still trying to figure out how you would do No, that doesn't make sense because Khan Academy doesn't do an AP exam. Thank you, Ty, for the follow. Yeah. And I'm trying to figure that out. If that's true, that's actually really impressive. Oh, yeah, that would do it. That would do it, yes. So I have a friend who, when I was a kid, he was taking, I think it was yeah. So that's possible. He would have had to have skipped a lot of them. You would have had to have skipped so many. You must be really good at math and have been for a while. But yeah, that's really awesome, user. That is really cool. I agree. That's really impressive. There aren't many high schoolers who are able to do that, but the fact that you're in middle school and doing that, dude, that's really impressive. You know what? That deserves a high five from me. So ready? There we go. I don't know if you high fived me, but I'll assume that you gave that I gave you a high five. So perfect. Like that is actually really impressive, dude. Yeah, I would take stats. But then the question is, what do you take after that? I'm not sure. I'm really not sure what you would do from there. Thank you, Mar, for sharing the live. I'm I'm sorry. I'm just I'm still in shock because that dude, that's awesome. That is really awesome. Congratulations. Definitely. I think he's right to teach some of the college students as well. Thank you, Mar, for the follow. Yeah, no, yeah, no, that's amazing. That is really amazing. Congratulations. But yeah, like I said, I don't even know after stats. I don't even know what you would take there. Maybe you said you took multivariable last year as a freshman, right? I think you did. Yeah, you said you finished multivariable. Multivariable is actually Calc 3. Yeah. You're gonna do great in like that, as long as you're able to dissect word problems, which given that you got a 5 on AP on your last two AP exams, that's not going to be a problem. That is amazing, man. Well done. Well done. We have a thank you Ease for the follow. Yeah, no, it's not often that um I'm not sure how yeah. Nope, not gonna have that. So yeah, no, I'm just that's actually legitimate. That's legitimately impressive, man. Way to go. Really? That I'm that's interesting. Bro, how does the 3x cubed minus 6 get factored? I don't get it. Okay, yeah, no problem. So, if I do oh, here, I'm not going I don't want to factor that because I'm looking at a function if this were with any other number here other than negative infinity, then I would want to factor that. If I did, I would probably use difference of cubes, but even then, it doesn't work out well. Is this AP pre-calc? No, this is this is calculus. So then, does it just disappear or what? So here, I'm using something called N behavior model. An N behavior model tells me that if as x gets kind of really high, this top part emulates 3x cubed. This minus 6, all that does is it just. So here, this minus 6, all this does, if we were to look at the graph of this and compare it to 3x squared, or 3x cubed rather, all this negative 6 would do is just move it down 6 units. And here, if I were to look at the graph of negative x squared, this 1 would just move it up 1 unit. But other than that, it would emulate the function with the highest power. So I guess in a way, yes, the -6 and the 1 disappear. Thank you, Jonathan's girlfriend, for the follow. Thank you. I don't know if that's a thumbs up or a fire. It looks like a thumbs up. So thank you, thumbs up, for the follow. Besides, constants are incredibly... yeah, yes, they are. So you can ignore... Because constants are incredibly small relative to infinity, so you can ignore their addition. Correct. Yes. Yes, you can. I have 72 new followers, and there's 73. Thank you, Anu, for the follow. I think that's a new record. So thank you, everyone, for that. I think I'm going to do a couple more, and then we will call it a day. Ooh. We'll save that for the final problem. We will save that one for the final one. Thank you, Clinton, for the follow. Can you help with linear algebra 2? I actually only took linear algebra 1. I'm not sure about linear algebra 2. Is this the L'Hopital rule? Nope. Can I use L'Hopital here? I don't think I can, because my limit is to infinity, and I don't think my limit can go to infinity with L'Hopital. Or could it? I don't think so, but I'd have to check again. Thought it would be just infinity because top has greater exponent. So it would, but remember that just because I'm taking my limit to infinity doesn't mean that the sign no longer matters. Thank you, Denny, for the follow. Cool. So we'll do 1 or 2 more, and then we will call it a night. So, you all are amazing, by the way. You're getting, I know, right? I think at the beginning of this month, I think I only had like, what? A couple hundred followers? Like 2 or 250? I don't know where I'm at right now. But as soon as I'm done this live, will have to check. So, let's do limit as x approaches infinity. Yeah, I know, right? I said that the goal for me was 1,000 followers by the end of the year, and it looks like that goal is going to happen a lot quicker than I thought. But it's only possible because of all of you. And so thank you for that. I really appreciate everyone who's in here watching. I appreciate everyone in here who's liking. I appreciate everyone in here who's following. I appreciate everyone in here who's sharing. And like I said, I appreciate all of you for even being in here. Because let's face it, you could have gone to a completely different live on your Wednesday evening. But the fact that you decided, hey, this looks interesting, or maybe it was recommended to you. But the fact that you clicked onto this live, I have to say thank you for that. I can't describe how thankful I am for all of you being here. You're doing great. You teach so well. Thank you, user. I'm really happy to hear that. There'll always be a demand for calculus tutors. Absolutely. That's why I'm here. Thank you, Geo, for the follow. Thank you, Cosmo, for the follow. So with that, thank you, Andrew, for the follow. So let's do 2x squared plus 5x over, let's have it be 10x to the 4th. That's it. Thank you. You're welcome, Kiki. I'm really happy to be teaching you tonight. We need more calc tutors in this world, definitely. And like I said, my goal of all of these lives is this. It's if I can inspire you to like math, even if it's just a tiny percent more than when you walked in tonight, then I've done my job. So here, let's add a plus 27. Why not? Doll World says 0. TikToker says 0. Let's see if you're right. So here, I want to ignore. So on the top and bottom, I'm going to look at only the values of x that have the highest exponent, because remember, when I'm taking the limit as x approaches infinity, I'm looking at end behavior model, and end behavior model tells me that the function in both the numerator and the denominator is going to closely emulate the part of the function with the highest exponent. Hey, Math Tutor, I am doing great. How about you? Thank you, Nicole, for the follow. So here, which one of these has the highest exponent? Is it 2x squared or 5x? Thank you, XO, for the follow. Math Tutor says 2x squared. Period says 2x squared. Yeah, that's exactly right. So here, this is going to be 2x squared. So I can ignore that 5x because my numerator is going to closely emulate that 2x squared as we get ridiculously large. So that's going to be 2x squared. And on the bottom, what is the part of the function in the denominator with the highest exponent? Something I realized I'm on this right now in Calculus 1. How much harder is this going to get? It's going to get a little more it's going to get more difficult, but this is a good part to start on, berries and cream. Good question. Excuse me. Rose says 10 to the 4th. Shah says 10 to the 4th. 10 to the 4th. User says 10 to the 4th. Sandy says x to the 4th. Jakey says 0. Absolutely. Jakey says as big gets bigger and bottom we reach 0. Thank you, Antonio, for the follow. Yeah, so a piece of this bottom function with the highest exponent is this 10x to the 4th. And so I'm going to use this rule here to simplify my x's. So I have x squared over x to the 4th. That's going to be equal to x to the 2 minus 4. 2 minus 4 is negative 2. So remember, x to the negative 2 is just equal to 1 over x to the 2nd. Thank you, Ryuku, for the follow. So now, this is going to be the limit, as x approaches infinity, of 2 divided by 10 is going to give me 1/5. And x squared divided by x to the 4th is 1 over x squared. So this is going to be 1 over 5x squared. Sorry. Thank you, Hazim, for the follow. I need to go get some water after this. So now, as x approaches infinity, my denominator is going to go is going to grow like a run. Is going to run away. We're going to have runaway growth in the denominator, meaning that I'm going to be taking one piece out of a pie that goes infinitely tiny. So it's almost as if I don't get any pie at all. The piece of pie that I get is so thin that it's essentially nothing. So it would be 0. What should you expect from Algebra 2? So you're going to be working a lot with, you're going to be learning a lot, you're going to take what you did yeah, so you're going to be dealing a lot with what I'm working on right now, but without the limits. I need to go grab some water quickly. I'll be right back in a second. There we go. There we go. You know, after 2.5 hours of talking, you would think that my throat would get dry, and it does. So, and you would think I would prep well enough to know, hey, you might want to get some water. But I'm like, nope. Apparently I am not. Thank you, 3 Vanda Goat, for the share. And thank you for the finger heart and the heart me. Again, I unfortunately I can't pronounce your name, so I apologize for that. Anyone want to do Delta Epsilon? I actually have that on my list of things to do. This is in business calc. Can I get advice on panicking? Business calc I actually don't have much experience with, just because I've never actually taken business calc before. Are you going on live tomorrow? I have calculus class tomorrow. Yes, I will be live at 11:30 p.m. Eastern. Can you go over absolute value equations? I don't actually have any prepared tonight, but I can go over. I can add it to the list. Absolute value. Please do a proof. I actually don't have any proofs prepared. Thank you, user, for the follow. I'm doing basic algebra and geometry review, probably some counties. That's cool. That's really cool. IBP. I don't quite know what that is. I'd have to look it up. Thank you, Marari, for the follow. What am I ignoring? Integration by parts. Right there. That is on my list. Can you do IVT and squeeze theorem for my friend? They're going to hop on the live in a sec. So I actually already did both of those over the last 2 days. Over the last 2 days. Good job, Robert. Let's try that again, shall we? So, I did IVT yesterday. And the day before that, we did... Nope, that's continuity. The day before that, we did squeeze theorem. Can you ask AI to give you equations for you to go over? So usually I like to only deal with, usually on a live, I usually like to go over only one maybe two subjects at a time, provided those two are basically the same topic. So like if I were to do, I might do lives where I have like, okay, send me in your questions and I will answer them live. But for now, I like to have it to where I only do 1 or 2 topics a night for now. That's not to say that I won't ever do a live where it's like, hey, ask me anything math-wise. Ask me any problem. But tonight, I just want to work on limit laws and limits at infinity. Can you go over hydrogen bonding between... Yeah. I haven't done chem in like 15 years. Actually, more than that. It has been a really long time. Can I derive Maxwell's equations? I'd have to remember what Maxwell's equations are to start with. Let me take a look. Oh, that's oh boy. Oh boy. Yeah, I wouldn't even know. I'll be honest, I wouldn't even know where to begin. You were joking? Fair enough. How many likes for Robert to do Orgo in the next live? Organic chemistry? I would be. Oh my. I. If I did organic chemistry on a live, it would probably be the most basic. It would be the most basic chemistry, organic chemistry. But even that, I'd have to brush up on. It has been years since I've taken chemistry. Period. I can have. Go for it. Awesome. Yeah. You. I'll give you organic chemistry. Period. I'm I'm gonna stick with what I know. But yeah. So let's try one more problem. And that will do it for the evening. So this is the final problem. Final problem of the night. Although I will be honest, I do have a habit of sometimes repeating topics. Like, probably in a couple months from now, once I get through a lot of the calculus that I need to, I'll either go on to a different topic or I will repeat what I've already done. Caitlin, thank you, Caitlin, for sharing the live. So to get to thank you, OMG, for the follow. Yep, this is definitely a new record. 87 follows. That's crazy. That I know of. I know some people even follow me afterwards. I have to stop joining it so late. I miss. No problem. Better late than never, Vosha. The and yeah, like I said, if anyone has any questions, even after a live, please feel free to send me a DM and I can definitely answer questions there too. You should do a definite integral. It is technically a limit at infinity. So yes, it's going to help you so much and low key use AI to create practice problems for you. Yeah, definitely. I would recommend that. All right, so to get to the final problem, there are 37 of us in here. I think 20k likes. Let's hit 20k likes and then we'll start the final problem. But yeah, like I said, hopefully, how's everyone doing? Is everyone having a good time? Everyone having fun? Because I'm having fun. This is fun. I think it is, at least. You're doing very well. Awesome, math tutor. Cool. But yeah, so let's see if we can't get to 20k likes. I know you can do it. I'll do a plethora of math problems. Awesome. And as far as the problems, I usually source them either from the internet or I have a few books that I draw problems from too. But sometimes I just don't like the problems that I find. So sometimes I'll just make them up on the fly. But yeah, so like I said, hopefully everyone's you're concurring. You're. I am concurrently studying Calculus 2 right now, so I can remember when I go to college in September. Cool. Just like the vibe of the stream. Awesome. I'm really happy to hear that, Clinton. And like that, math. My goal is to do math at a nice, relaxing pace. There's no. I'm not gonna rush here. Um, we're just gonna do math. We're gonna. I feel like I would scare off all of Robert's followers if I started teaching Orgo. I don't think so. Yeah. No, if you when you go live, if you I'll watch some of your organic chemistry lives because as as I like to teach math. I like to learn new things as well. Is taking calculus 3 in the winter a good idea? Are you that depends. Are you taking calculus 2 now? I mean, yeah, it's a good idea to wait, but especially if you feel like you're not ready for calc 3. Cool. Yeah, taking calc 2 before calc 3 is a good idea. So yeah, I would wait until the winter. My major makes me take calculus 3 after linear algebra and differential equations. Cool. Yeah, I would too. I would definitely watch periods lives. How close? Just out of curiosity, period. How close are you to being able to go live? I took up the calculus 2. I'm done math. I'm majoring in genomic medicine. Would anyone watch my live if I taught calc 1 or 2? Yeah, definitely. What would life be without calculus? I don't want to know the answer to that question. No, siree. I do not want to know the answer to that question. But yeah, so I think let's go ahead and do the final problem of the night. I tutored people in chem and math when I was taking my classes. Very good studying mechanism. Yeah. I forget who says it, but someone said that the best way to understand something is to teach it to someone else. Let me take a sip of water because I need to. Cool. So, have I talked about graphical investigation of limits? I don't think I have. I'd have to check. You should do bio? Go for it, doll. Go for it. So here, let's find the limit as x approaches infinity of the following. So let's do negative 3x squared minus 2x squared all over x cubed, or no, x squared plus 5x minus 6. What do you think that would equal? I'll give you a moment. Say so says you're not sure. That's okay. Thank you for being honest. That is an answer. Thank you, Drew, for sharing the live. What do you think the limit of this would be? Thank you, Math Tutor, for sharing the live. You know the answer, but you won't spoil others' learning. Okay, Clinton. Doll World says infinity. Omid says -5. Okay. Doll says you add both x to the fourth. Okay. Thank you, Rita. I don't know if that's an exclamation mark or an L. It looks like an L. So thank you, Rita, for sharing the live. So the numerator higher. Okay. Jeffrey says 0. Okay. Doll World says -infinity. Okay. Shaw says -3 minus 2 becomes -5. Okay. Omid says it's -5. X squared cancels out. Drew says -5. Cheyenne says -5. All right. I'll give people until another couple minutes to do that. And while we're doing that, Math Tutor says -5. So it looks like we're starting to come up with a consensus. Cheyenne says because you put everything under x squared. Okay. Roach says -4x squared over 5x minus 6. Shaw says -5x squared all over the denominator, then divide by x squared. Yoshi says 2. Okay. So let's see what the answer is. So here, in the numerator, remember I'm looking for the highest power, but I have two things that are the same power, which means that I can combine my like terms here. So -3x squared minus 2x squared. That gives me -3 minus 2 gives me -5. And x squared comes along for the ride. And now on the bottom, remember I'm looking for the highest power of x, and that's going to be this x squared right here. So the end behavior of this bottom is going to be x squared. So this is going to be x squared. So I have -5x squared over x squared. Well, I can say bye to my x squareds. And I would be left with limit as x approaches infinity of -5. And remember, limit as x approaches any number of a constant is just that constant. Do I do any stats? Yep. I actually haven't done stats in a little while, but is there anything in stats that you want me to cover? Can't you factor x squared in numerator? I could. But instead of doing that, I can just combine those two, because they have like terms. That is negative, right? Oh, negative. I could. But again, it doesn't really make sense to do that. Please do stats at the beginning. I'll consider some stats. Right now, the plan is to finish out limits and get into derivatives by the end of the week. And the bottom factors, it does. But again, because I'm taking the limit as x approaches infinity, this whole thing is gonna closely emulate the term with the highest exponent. Where did the constant go? Here. So again, as x approaches infinity, I'm looking at what's called the end behavior model of my denominator. So the end behavior model of my denominator says, okay, as x gets ridiculously large, which one of these is going to have the most influence over my function? That would be my x squared. So everything else, essentially, I don't want to say it goes away, but it kind of goes away. I just started AP Stats and was wondering what a problem may look like. Okay. Yeah, I can get into some stats here soon. Do I have a channel over there? Yes, I do. It is right here. Thank you, Vanessa, for the follow. You could factor x squared from both numerator and denominator. Yeah, I could have. When I got down here, yeah, absolutely I could have. Yes. In fact, here is everything that I tutor. And differential equations is right there. So yes. Like I said, when it comes to these lives though, I like to try and focus on one or maybe at the most two, if they're related, subjects to get in a live. Is that the only strategy? No. So some books will have you look for the highest power overall and divide everything by that power. So here, instead of using in behavior model, I could have done, okay, I have limit as x approaches infinity of 5x squared, of negative 5x squared, all over x squared plus 5x minus 6. Some books will tell you, okay, x squared is the highest power overall, so we're going to divide everything here by x squared. So this would be limit as x approaches infinity of negative 5x squared over x squared divided by x squared divided by x squared plus 5x over x squared minus 6 over x squared. As you can see, this has the potential to get really messy really quickly. So rather than deal with that, I prefer using this method. Is that I took Calc 3 like 3 years ago. How hard will differential equations be next semester? So differential equations, since you I would brush up on my derivatives and integrals. Differential equations, if I remember correctly, integration is going to solving differentials is going to be, and I mean it's obvious because that's the name of the class. So differential equations tends to be if you took Calc 3 and you review your Calc 3 and your Calc 1 and 2, you should be fine. But yeah. So with that, we'll go ahead and call it an evening. I think this is my longest stream ever. I caught you late. Do I have time for one problem? Yeah, I think I'm done for tonight. But yeah. So I'm going to try and start posting. What am I doing next? So tomorrow, I'm going to be doing limit definition of the derivative. If you want IDK, feel free to DM me and I'll answer your question there. So yeah, so before I go, I'll give you my usual outro. So here, if you want to find me elsewhere, you can find me here, and this is my channel. So if you hit these 5 things, if you do these 5 things when you're there, that would be awesome. I'm working on a Calc 1, 2, and 3 series right now. The first episode of that should be out by Friday. I'm going to be recording it tomorrow and editing it tomorrow. Excuse me. And then, and you'll be able to find that here. And then if you want to, or if you're interested in following other people on TikTok, I highly recommend you follow these two. So if you're taking your, so if you're taking your ACT, your ASVAB, your Acuplacer, your PSAT, I know she's offering help with PSAT for those who are going for the National Merit Scholarships. You should follow ACG Math Tutoring. Thank you, Ducky, for the follow. And then, so she was the one who convinced me to join TikTok to start with. So definitely give her a follow. And then I also recommend you follow Learning with Lynette. She teaches the Abacus. She was actually the one earlier who I think invited me to go live with her. So that will be interesting. But yeah, Learning with Lynette's amazing. So I definitely recommend that you follow both of them. And then I said earlier that I tutor, so I offer online math tutoring. Might help if I flip it that way. Thank you, Ducky, for the follow. So I offer group tutoring and I offer one-on-one tutoring. So for group tutoring, I offer tutoring to groups of 3 to 10 students who are all taking the same class. Now, that doesn't necessarily mean that you're taking it with the same teacher or even at the same school. You just have to be taking the same class. For example, if you and 2 of your friends are taking Calculus 2, then you can sign up for group tutoring, and I charge you $35 per hour per person. And then if you are interested in one-on-one tutoring, I'm running a special right now where normally I charge $100 an hour, but if you sign up for weekly tutoring from now until August 31st, you're going to be locked in at this rate. So even after this date, if you sign up now, before August 31st for regular tutoring, which would be weekly, then you would be locked in at this rate. Because on September 1st at 12:01 Eastern, my rate goes back up here. And here are all the subjects that I tutor. Is AP Calc BC worth it? Absolutely. Absolutely it is. So with that, I'm going to go ahead and call it an evening, or should I say morning, because it's 2:30 here in Maine. So with that, I hope everyone had a fun time. And remember, if you enjoyed math even a tiny bit more, if you like math a tiny bit more than when you joined tonight, then I've done my job. So with that, have a great rest of your evening, everyone, and I will see you tomorrow at 11:30. Bye, everyone.